Take an idea from its roughest form through all the many steps demanded close teamwork between the engineer and designer, coupled with experience of the highest order. It demands also the use of all the mechanical and electronic assistance available in a modern and well-integrated engineering effort. From this team effort, from the day by day, week by week, and month by month detailed development, data study and analysis, a form and an idea took final shape. Mountains of detail having to do with all phases of the job. Cubic yards of earth to be moved, the final installation of the reactor itself had to be established, checked, and rechecked, until finally, three-dimensional and solid, the idea grew to a complete model. It consisted of these basic elements. The spherical steel vapor container housing the nuclear reactor itself. The turbine building where the heat from the reactor would drive the generator. The office building for administration of the project, and several other structures we shall touch on later in more detail. Yes, at this point, an idea had been made tangible, measurable, an idea for pioneering with power from the atom in the best New England tradition. Only one thing remained: build it. The date, September 4th, 1956. The operation, preliminary land clearing and radiation monitoring. But in other language, seen against the ageless hills, the beginning of another story suitably fitted to the long traditions of which these hills have been a part. After that initial date, significant moments strung themselves together like beads on a chain, thanks to planning and execution of the plans according to a carefully developed schedule. March 17, 1958. Hungry tools biting out huge mouthfuls of earth, changing the face of the land. April 11, 1958. The first of more than 2,500 tons of concrete to support the 125-foot diameter steel sphere, the 175-ton pressure vessel and its auxiliary equipment. Upon this concrete would rest the 8 reinforced concrete columns and the 16 steel pipe supports for the steel sphere. June 20th, 1958. Arms of steel for the turbine hall, where the turbines driven by the heat generated in the sphere would eventually produce 136,000 kilowatts of power to feed into the power network of New England. It is a mighty story and an exciting story. These scenes of continuing activity, of bringing order and form and pattern out of the raw and stubborn earth, out of inert steel and fluid concrete. This story of bringing out of the reams of paper, the models, the plans and specifications, something massive and solid, something, too, with a significance in its very conception that probes long fingers into the future. For it is truly the job of the pioneer to seek, test, yes, even gamble, to discover the answers that must be known before information can become progress, and progress can provide measurable benefits to mankind.
Liga ve ich an die Börse erfolgreich. Ist die Börse wirklich riskant? Helfen wir, die ganzen Lügen?
Another major date, September 26, 1958, when the last steps are taken to prepare for pouring of the initial concrete for the reactor structure itself. Sinews of steel, most of it 2 inches in diameter, for the tons of concrete which will be placed in one continuous pour so that the base of the reactor structure shall be without seam or joint. For 10, 20, 30 hours and more, the 3 derricks swing a continuous bucket brigade of the steam. Better than 2,000 tons of concrete webbed and sinewed by more than 100 tons of steel. 1,000 cubic yards of continuous pour, a feat to test machines and men alike. But a feat that is accomplished as planned, and the huge saucer-like base of the internal reactor structure takes its final shape, supplies the strength and protection needed for what is to follow. Other areas of the unique complex of buildings take their final shapes as well, and as the weeks go by, the complete plan begins to emerge. With a gross weight of some 1,400 tons and a diameter of 125 feet, the outer skin, the final protection for the reactor and its associated equipment, goes on. Many of the individual plates are machine welded on the ground into sub-assemblies. Each weld is X-rayed. And when the plates find their final place, the total length of welds alone runs to 1.5 miles, about 50% hand and 50% machine welded. And perhaps here, as the final steps are taken on the reactor sphere and the rest of the installation becomes each day more and more completed, would be a good time to stop for a moment and see just how the plant operates. As we saw previously in more detail, the splitting of the uranium atoms under calculated control produces intense heat. Enough, actually, in this plant to compare to the output of a steam boiler plant 15 stories tall. The heat from the fissioning material heats water that flows through the reactor core. The water is held under 2,000 pounds pressure to prevent steaming. This heated and pressurized water then is pumped through the steam generator, where it heats the water in the secondary system, transforming it into steam. This steam, as in any conventional steam generating plant, turns the turbines which produce the electric power. Yes, this is how pioneering with atomic power looks from the outside. And from here on, it is what happens inside that counts. Of primary importance is the neutron shield tank. Into it, the reactor itself will be set. The top section is a very heavy steel plate to support the weight of the reactor vessel itself. A 5-foot concrete wall surrounds the water-filled tank. The reactor consists of a heavy steel tank, shown here arriving by rail. This 30-foot-long tank has an inside diameter of 9 feet. Into this vessel will go the fuel assemblies containing 26 tons of uranium. Since the vessel will operate at a pressure of 2,000 pounds per square inch, it was built with walls 8 inches thick. The reactor, weighing 175 tons, was hoisted into the sphere by means of a powerful crane, which also placed the steam generators and other heavy equipment. With the neutron shield tank installed, the actual reactor vessel is now lowered into place. So, after years of effort, planning, decision, and construction, the reactor itself becomes a part of the system. Next is one of the 4 steam generators which utilize the pressurized water heated by atomic fission to make steam to run the generators themselves. Arriving from the supplier by flat car, the transfer of it from car to its final resting place is a